So this is the question that was sent. That This question asks you to investigate some properties of hexagonal numbers. Hexagonal numbers can be represented as dots, as shown below, where h of n denotes the nth hexagonal number. N belongs to n. That means n belongs to natural numbers. What are natural numbers? That start with 1, 1, 2, 3, 4, like that, right? Note that 6 points are required to create the regular hexagon H2. So we have labeled that also, that 6 points are required for the second one. For the third one, if you count, it will be 15, and that's what they have written for 15. Okay. Um, so they are asking first, write down the value of H5. Okay. What pattern do we see here? We see that between 1 and 6 there is a gap of 5. Okay, and then between 6 and 15 there is a gap of 9. Okay, let's see the next one first. Let's count that. Is it making a gap of 13? Let's see that quickly. So we start from here. Let's start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is outside. Then inside part is 19, 20, 21, 22, 23, 24, 25. Okay, 26, 27, 28. Right. So these are 28. So as expected, this gap is going to be how much? This is 15 plus 15 to 28. The gap is 13. So the next they are asking, write down the value of h5. So h5 accordingly will be what? It will be a gap of 17 from here, because 13 after 13 there should be a 4 gap of, so 17. So 28 plus 17 becomes 45. So your first answer is 45. So this is like a one marker. It's like just asking you to go through it. Okay. So let me just write that. Yeah, so 45 is the first answer. Now they are saying, by examining the pattern, show that h of n plus 1, that means let's say 5, okay, this is equal to hn plus 4n plus 1. Okay, so let's take the first case. In the first case, you see h2 is equal to h1 plus 4 times 1. uh, yeah, plus 1. So that comes out to how much? H2 is equal to 6. 6 H1 is, we know, is 1. So 6 equals 6. So pattern holding true for H1 and H2. Let's check for the next one also. H3 and H2. So H3 is equal to H2 plus 4 times. Now in this case we have taken n as 2. So 4 into 2 plus 1. So that comes out to how much? H3 is how much? H3 is 15, right? So 15 is equal to 6 plus 4 times 2 is 8 plus 1. So 15 equals to 15. Holding true even then. So there, this pattern does hold true. By, you can examine the pattern and you can show that, it's holding true for H1, H2 and H2, H3. And since it's a 3 marker, you can also do one more. So you can do H4 is equal to H3 into, sorry, not into, plus 4 times n. N is what in this case? 3. So 4 into 3 plus 1. So that comes out to how much? That comes out to h of 3 is 15. H of 4 is how much? 28. Yes. Uh, 15 plus 4 times 3 is 12 plus 1 is, so 28 equals 28. Therefore, pattern holds true, right? Hn plus 1. So since this pattern is being followed, this pattern is being followed, it can be observed, uh, pattern being followed, it can be between observed between n equal to 1 to n equal to 4, right? So it's working out. Okay, now let's see, by expressing hn as a series. So now it's series. Okay, so series are what types? One is arithmetic and one is geometric. That's what we know. Okay, now arithmetic can have either a common difference like this, 1, 3, 5, 7. So in this case the common difference is 2, right? And it's on the first level. So it becomes very easy to find the nth term in this case. So nth term is nothing but Tn is equal to T1 plus n minus 1 times d. D is the common difference. So in this case, let's say I want to find the fifth term. My difference is 2, right? And fifth term, that means n is 5, 5 minus 1 is 4, okay, and t1 is 1. So t5 is equal to 1 plus 5 minus 1 into 2. So 1 plus 4 into 2 is 4 into 2 is 8. 8 plus 1 is 9. So t5 is equal to 9, right? So that is a basic arithmetic sequence where the difference is met in level 1 only, right? Uh, but in this case, what is happening is we have a sequence which is coming out something like this: 1, 6, 15, 28, 45, right? So let's just quickly, I'm just erasing this part. I think it's clear right now what I just said. Let's, just a second. Going back to the thing. So the series is coming out as 1, 6, 15, 28, something like that, right? 45, yeah. Now, let's see where are we getting a common difference. When we do the first time, we are getting a difference of 5 and then a 9, okay, and then 13 and then 17. So what's really happening here is that at the first level, okay, the common difference is not being met, okay, but at the second level it is being met, because we know there is a difference of 4 and 4 over here. So when is it meeting? This was the first level, this is the second level. So at the second level we are getting a common difference, right? So what we'll do is we will define our nth term of this series. Firstly, what type of series is this? This will be a quadratic sequence, okay? So what that means is that, 4 4 4, it's meeting at the second level. So quadratic sequence means the degree of nth term is going to be 2, okay? So your nth term is going to be something like Tn is equal to an square plus bn plus c, okay? So so let's start. Firstly, we have the first term as 1, right? So let me just change the color. Let me take another color, okay? So the first term is 1, and what we are going to do is let's put n equal to 1. So that means a into 1 square plus b into 1 plus c. So we have a plus b plus c, right? This is our first term. So what we'll do is above the 1 we'll write a plus b plus c. Okay. Then the next term we'll see is 6. Okay. For 6, n is equal to what? N is equal to 2, right? So let's put n equal to 2. So what do we get? A into 2 square plus b into 2 plus c. So that becomes 4a plus 2b plus c, correct? So this is 4a plus 2b plus c. And similarly, if you do the next one, it will become a into 3 square plus b into 3 plus c. So that becomes 9a plus 3b plus c. Okay, I think this much is clear so far. Okay, then let's go further ahead. What we'll do is we'll subtract 6 minus 1. So we know 6 minus 1 is 5, right? Similarly, what we'll do is we'll subtract 4a minus a. So that becomes 3a. Okay, and 2b minus b becomes plus b. What happens to the c? C and c cancel, right? Similarly, let's do it for the second thing. 15 minus 6 is 9, right? Let's do 9a minus 4a, that becomes 5a, okay? Then 3b minus 2b becomes plus b, okay? Then we subtract 5a plus b minus 3a plus b, so that becomes 2a, right? Similarly, let's see here also. If you took the fourth term, so that was 16a plus 4b plus c, right? So if I subtract that, I get 7a plus b again. So if I subtract 7a, this 13 minus 9, I again get 2a here. Yeah. You can rewind and watch if you didn't get how I got these. Okay, so what I'm understanding is that 2a is equal to 4. Let me just change the color and make it a little more yeah, okay. So 2a is equal to 4, so a is equal to 2, right? Okay, then what do we have? Let's put that over here. So we know that 3a plus b is equal to 5, correct? So 3 into a is, what did we find a as? A is 2. 3 into 2 plus b is equal to 5. So 6 plus b is equal to 5. B is equal to negative 1, right? So you have your negative 1 as well. Now let's put in the first case a plus b plus c. So a is 2, right? B was negative 1. So 2 plus negative 1 plus c is equal to 1, right? So that means 2 plus negative 1 becomes 1. So 1 plus c is equal to 1. So therefore c is equal to 0. So what is your nth term being formed of this series? Or in this case, it will become Tn is equal to an square. A is what? A is 2. So 2n square. And what was b equal to? B was equal to negative 1. So negative 1n or negative n. Yeah. So Tn, or you can write it as Hn, is equal to 2n square minus n. So this is a quadratic sequence. If you have doubt, I'll send you more videos like this, but this is how you do the first three parts. Okay. Then they're saying determine whether 2016 is a hexagonal number, right? So 2016 is a hexagonal number. How would we know that? We'll simply put, instead of Tn, we'll put 2016. So we have 2016 is equal to 2n square minus n. Now, when is it going to be a hexagonal number? When you have this, when you will solve this quadratic equation, and it will you will get a positive value of n. So you will be then sure that 2016 is a hexagonal number. So what we'll do is we'll bring the 2016 on this side. It will become 2n square minus n minus 2016 equals 0. So let's solve that quadratic equation. You can do that. You can solve this quadratic equation. So that will give you the fourth answer. If you get a positive n value, like n equal to 25 or something, or n equal to 85, then you can say yes, nth 85th term is 2016. So 2016 is a hexagonal number if you get something like that. Find the least hexagonal number which is greater than 80,000. So that means you have to take some value of n which is greater than 80,000. That means 2n square minus n has to be greater than 80,000. So very simple. You first take it equal to 80,000. Whatever value you find out, the positive value of n, you take that, and let's say you get something like 45.44. So you know that the next n cannot be 45.44. N will be 46. So the 46th term will be greater than 80,000, right? So that way you can work out. Sorry, yes. Well, consider the statement 45 is the only hexagonal number which is divisible by 9. Is that true? Let's see. Are we getting another number